Hello everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson metabolism. Okay, first we will look at enzymes. So enzymes are biological catalysts that can increase the reaction rates. So enzymes are highly specific when you compare with the normal inorganic catalysts. So what is meant by specificity? So one enzyme can catalyze only one type of reaction. So to explain the specificity of enzymes, we use lock and key model and the induced fit model. So according to the lock and key model, the enzyme and the substrate will fit like a key and a lock. So you can see here, so this is the enzyme. So enzyme has an active site. The shape of the active site must match the shape of the substrate. According to the induced fit model, the enzyme's active site shape will slightly change to better fit the substrate. So that's the main difference between the lock and key model and the induced fit model. And enzymes are also more sensitive at high temperatures, or when you change the pH, enzymes can denature, which means enzymes will lose their activity. Okay, so enzymes denature. So enzymes denature or loses their activity due to the changes in pH. We'll see why now. So proteins overall 3D structure is due to the different types of interactions between R groups. So we know enzymes are proteins, and proteins overall 3D shape structure is due to the interactions between R groups. So changes in pH can change the ionization of R groups, and this can disrupt the bonds between R groups. As the tertiary structure of the enzyme is disrupted, the enzyme's active site changes shape and enzyme activity drops. So what happens now? So when you change the pH, the ionization of R groups can change. So this can change the interactions between R groups, which will result in change in shape of the enzyme's active site. So therefore, the enzyme activity can drop. And also enzymes denature at high temperatures. So when the temperature is higher, what happens? The increased kinetic energy breaks some of the bonds between R groups and new bonds will be formed. So this will change the shape of the active site. If the shape of the active site is changing, what will happen? The enzyme will lose its activity. So therefore we say the enzyme is denaturing. So the enzyme can denature then at high temperatures and also due to variations in pH. Okay, comparing denaturation with hydrolysis. Okay, so what happens in the denaturation? We know the enzymes, so enzyme is losing its activity. The denaturation can disrupt the secondary, tertiary, and the quaternary structure, but nothing will happen to the primary structure of the protein or the enzyme. However, the hydrolysis will break the primary structure, because during hydrolysis, it's breaking the peptide bonds between amino acids. The hydrolysis of proteins or enzymes will break the primary structure. So therefore, the peptide bonds are breaking, and the polypeptide chain will break into amino acids during hydrolysis. But during the denaturation, the primary structure is not changing. Okay, so now we look at starch hydrolysis. So starch hydrolysis starts in your mouth, where starch by amylase, it's going to maltose, which is a disaccharide. So starch is a polysaccharide. So by amylase enzyme, starch is becoming maltose. And then maltose by maltase enzyme in the small intestine, it's becoming glucose, which is the monosaccharide. So glucose will burn to produce energy, right? So that's the cellular respiration. And excess glucose is converted to fat for energy storage. And also some of the glucose molecules will convert to glycogen. Glycogen is the energy storage molecule. So the glucose will also be converted into glycogen by condensation reactions. Then the cellulose hydrolysis. So we don't have cellulase enzyme to hydrolyze cellulose. Therefore, we can't get energy. So cellulose is the dietary fiber that we take. So we can't get energy from cellulose or fiber. So then the lactose hydrolysis. So which enzyme we need for lactose hydrolysis? It's the enzyme lactase, which hydrolyzes lactose to glucose and galactose, right? So lactose is a disaccharide and it's going to glucose and galactose. Okay, so what is this GI value? So GI value ranks food according to the effect on blood sugar levels. So if the food is releasing glucose quickly, so then we say this food is high GI, right? And if the food is releasing glucose slowly, then we say that food is low GI. Okay, so we say whole meal products, they have a low GI value than products made from white flour. So what's the difference? Why there is a difference then? So the grains used to make whole meal products contain husk. So the outer husk is made from cellulose and the particle size are also large. So we know that we don't have cellulase enzyme to hydrolyze the cellulose, which means the rate of hydrolysis is it's slower here, right? So we don't have a cellulase enzyme, and also the particle size is large, which decreases the surface area. So due to both these reasons, the rate of hydrolysis of those products are slower. So therefore they release glucose slowly. Therefore I can say these food are, the whole meal food are low GI. Okay, then we compare the GI values of carbohydrates or starch consist of amylose and amylopectin. So we learned that amylose is a starch which is linear and amylopectin is a starch which is branched. So linear structure and polymer chains can pack tightly. It is insoluble in water. Amylose is insoluble in water. So due to both these reasons, there is a less access for enzymes and rate of hydrolysis is lower, right? So because it's linear structure, right, the molecules can pack tightly and also it's insoluble in water. So because of those two reasons, the enzymes are not accessing them easily. So therefore the rate of hydrolysis is slower. Okay, hydrolysis of proteins. So proteins hydrolyze by the enzyme pepsin to produce amino acids. We know the proteins are made from amino acids. So the hydrolysis of proteins by pepsins is giving amino acids back. Okay, then the triglycerides hydrolysis. So large triglycerides by bile, they will we say emulsification, they are going to small droplets of triglycerides, which has a greater surface area. Now lipase enzyme act on them to break them into fatty acids and glycerol. The fatty acids and glycerol will reform new triglycerides, and these triglycerides will be stored in adipose tissues and used as an energy source. Okay, so that's the end of this video. So now it's time to do questions. You can practice questions from RoshChem 3 and 4 study guide. You can find questions on pages 142 to 149. And thanks for watching my video. If you need any further information, visit our website www.roshchem.com. Thank you. I'll see you in another video.